Okay. So let's have this problem. Okay. A W wide flange 8 by 21 shown is used as a tension member. It carries a dead load of 133 kilonewton, including its own weight. What would be the additional service live load it could carry? Okay. So, una, we need to check it on the tension yielding or the yielding natin, tensile yielding and tensile rupture. Okay, since we are not yet dealing with the black shear. Okay. So, unahin muna natin dun sa ating tension yielding. Okay. So, this could be under yielding. Okay. Or you have here the tensile yielding. Okay. So, for the P sub n, we can have it as Fy multiplied by our Ag. Okay. By the way, this is A36. Okay. A36. Okay. So, we will have, okay, pag walang binigay na Fy, so we will use 250. 250, no? So, we will be having here 250. So, we can have it as megapascal. And then, the gross area would be 3974. Okay, naka-newton yan. So, i-divide na natin by 1,000 para maging kilonewton. So, we will now have the nominal axial tensile capacity of 993.5 kilonewton. And this is on the tensile yielding. Okay? So, punta tayo ngayon sa pangalawa. We will be having here on the tensile rupture. Okay. So, on the tensile rupture, we need to get for the P sub n also. Okay. But this time, this is equal to Fu multiplied it by our AE. Okay. While the AE is equals to U multiplied by the AN, or the shear lag factor multiplied by the net area. So, we need to solve now for the net area. So, our net area would be equals to A gross minus area ng hole. And if you have here the staggered connection, so you have S squared plus 4G multiplied by T. But for this problem, we do not have a staggered connection, so that would become equal to 0. So let's solve for the A sub n. So A sub n is equals to 39, okay, 74 minus apat yung hole. This is actually the cross section. So meron kang apat na hole. Okay? And then that is on the 18 mm bolt. Mag-a-add tayo ng 3 mm. Okay? And then multiply natin ng thickness kung saan siya nakakabit. So since nakakabit siya dito sa ating flange, so ang thickness ng flange mo is 10.2. So that's around 10.2 mm. Okay? So this is now the area of area net, no? So 3974 minus 4 times 18 plus 3 multiplied 10.2. Okay, so that's around 3117.2, okay, mm squared. So to get for the value of AN, we need to find for the effect shear lag factor. Okay, so U, okay, we need to solve for this shear lag factor. Okay, so meron tayo una, case 2. Okay, so case 2 natin, yung U natin equals to 1 minus bar X all over the L. Okay. Kaya lang, for the W section, ang ginagawa natin, kukunin natin yung kalahati niya na, no? Okay, so pag kinuha ko yung kalahati, it would be on this figure. Okay, so parang ganyan magiging figure mo. Okay. And then, this now would become kalahati WT. Okay, magiging WT section na siya. Tapos kakalahatiin mo lang din to. So, you will be having here 4 by 10.5. Okay, dun sa table nyo, okay, may makikita kayo dong cross-section na WT 4 by 10.5. Okay? And then, nandito yung atin. Okay, so yung magiging bar X natin, this one. Okay? Ngayon, dun sa table, on the AISC, this is called the bar Y, no? Okay, on the AISC table. Okay, kung meron tayong steel table, iyan yung bar Y mo, no? Pero, that is actually the bar X dun sa ating formula. Okay? So, dito makikita natin, looking for the AISC, yung bar Y niya, that would become equal to 21.11 millimeters. Okay? And iyon yung gagamitin natin as the bar X. Okay? So, we will now have U is equals to 1 minus, ang bar X ko is 21.11. And then, I will divide it, okay, by our total length. So, total natin is tatlo daw na 75 mm. So, 3 times 75. Okay? So, that's around 225. Okay? So, with this formula, makakakuha ko ng U equals to 0.91. Okay? Pero, aside from that, since this is a wide flange section, yung K7 is also applicable. So, check natin on your K7. Okay, K7 tayo. So, i-check natin yung ratio ng kanyang BF or kanyang wide flange all over its depth. So, check natin si BF all over D. Okay? So, ang BF natin is 133.9 and then ang D natin is 210.3. Okay? So, that's around 0.64. Okay? So, kapag ito is less than 2/3, okay? So, ang 2/3 natin, 0.64. Okay, sa condition natin, this is less than 2/3. Okay, based on the table, and then, ang U daw na gagamitin natin is 0.85. Okay, so meron tayo ngayon dalawang U. Isang 0.91 at isang 0.85. Okay? Sabi ni NSCP, if two cases are applicable, you may use, okay, larger U. Okay? So, tayo, we will use U equals to 0.91. Okay? Now, we will be having here for the AN. Okay, so let's solve for the AN. So, that's equals to U, AE. Okay, let's have it for the AE equals to U multiplied it by AN. So, that is 0.91. And then, the AN natin is 3,117.2 mm squared. Okay, so let's solve for this one. So, 0.91 times 3,117.2. Ay, sa dami. 3,117.2. So, that's around 2,836.65 mm squared. Okay? So, pwede na tayo ngayon kumuha ng P sub N. So, P sub N natin is equals to FU multiplied it by AE. So, we will be having here as FU 400 multiplied by 2,836.65 and i-divide ko namang 1,000 para maging kilonewton. So, I have here 400 times 2,836.65 all over 1,000. So, you will be having here 1,134.66 kilonewton. Okay? Now, gagamit tayo ngayon ng dalawang method, no? So, walang binigay kung anong method yung gagamitin mo. Okay, tinatanong is on the service live load, no? So, check natin una for the LRFD. Okay, using LRFD. FD. Okay? So, for the yielding, we will be having here, okay, we will be having here PU is equals to 0.9 of P sub n. Okay? So, check 0.9 of the P sub n is 993.5. Okay? So, this 993.5 is actually the PN on the tensile yielding for 993.5. So, you will be having here 894.15 kilonewton. Okay? While using the ASD, so we will be having here as PA is equals to PN all over 1.67. Okay? So, using this one, okay, so 993.5 divided by 1.67, you have there 594.91. Okay? So, for the tensile rupture, okay, this is for the LRFD and then this is for the ASD, no? So, again, this one is ASD na to. Okay? And then now, let's check for the tensile rupture. Okay. Okay? So, we will be having here PU equals to 0.75 of P sub n. Okay? Ang P sub n ko na gagamitin is now 1134.66. Okay? So, we will have it 0.75 times 1134.66. So, you have here 809.95. Okay? And I can also using the ASD, P sub A. So, that is equals to 1134.66 all over 2. So, you have here 1134.66 all over 2. Or that's around 567.33 kilonewton. Okay? Next, after you have then, pwede ka lang makakuha ngayon ng P. Pwede tayo makakuha ng PU, no? Okay. So, for the ultimate, kukunin natin mas mababa between the yielding and then on the rupture. So, sa yielding natin, meron tayong 894. And then, sa rupture natin, meron tayong 850. Okay, so, kukunin natin 850.995. Okay? And then, we will now have the PA equals to, mas mababa sa dalawa, isang 594 at isang 567. So, we will be having 567.33 kilonewton. Okay? So, additional live load, okay, service, okay. So, using the LRFD, so we will be having here yung PU natin equals to 1.2 dead load plus you will be having here 1.6 of live load. Okay? So, we will be having now the PU 850.995 is equals to 1.2. Ang dead load natin is 133. And then, you will be having here plus 1.6 of live load. Okay? So, may makukuha tayo ditong live load and that is actually the service live load na hinahanap natin. 0.995 is equal to 1.2, 133 plus 1.6 of X. So, you will be having here 432.12 kilonewton using the method of the LRFD. This is now the service live load na kailangan natin, no? Now, for the USD, we will be having here PA equals to dead load plus live load. Okay? So, ang PA natin is 567.33 is equals to, ang dead load natin is 133 plus live load. Okay? So, makakakuha tayo dito ng live load equal to 567.33 minus 133. So you have here 434.33 kilonewton. Alright. Now, I want you to see yung dalawang live load, no? Even though ginamitan natin both the methods of the LRFD and then the ASD, still, if we are talking about the service load, kung mapapansin nyo, almost same lang sila, no? So, sa LRFD, we will be having 432.12, and then for the live load, we have, for the ASD, we have now 434.33 kilonewton. Okay? So, again, either of the two, pwede mo yung ma-solve, no? Okay? So, this is for this problem. Again, I have to save it. Okay. Okay, so let's have this problem. Verify both the ASD and LRFD, the strength of L 100 by 100 by 4. So ASTM A36 with one line of 418mm diameter bolts in standard holes. The members carry a dead load of 89.96 kN and a live load of 266.89 kN in tension. Okay. So, dalawang methods ang gagamitin natin. So, pinakamaganda niyan, ang gawin muna natin is we try to find for the nominal. Okay? So, let's have it the solution. Alright. Okay? So, unahin muna natin for tension yielding or tensile yielding, failure, or limit state. No? So, we will be having here Pn equals to Fy multiplied it by the Ag. Okay? So, gamitin ko is 250. So, kapag walang binigay, we may use 250. Sometimes, it's 248. Okay? 250 multiplied it by the Ag, 2619.45. Okay? And then, I will divide it by 1,000 to be in kilonewton. So, that you will be having here 654.86 kilonewton. Okay? And then check natin now for the rupture. Okay, so on the rupture strength, we will be having here as Pn equals to Fu multiplied it by the AE. Okay? So, unahin muna natin si An. So, because AE equals to U multiplied it by the An. So, unahin ko muna si An. So, ang An ko is the gross area minus area ng hole. Wala lang S squared over 4G multiplied by T because wala naman tayong staggered. So, we will be having here as 2619. Okay, 0.45. Okay, minus, isa lang naman yung hole natin. So, 14 multiplied it by 18. And I will add here 3 mm. Okay, so we will be having here net area equal to 2619.45 minus 14 multiplied by 18 plus 3. So you will be having here 2,325.45 mm squared. Okay. So, yun. Meron na tayong isang An. And then, we'll try to find for the shear lag factor U. Okay. Shear lag factor. Okay. Let's try it for the case 2, no? So, unahin muna natin si case 2. Okay. So, meron tayong U is equals to 1 minus bar X or over the L. Okay? Yung L na gagamitin natin, actually, that is the bar Y kung nasan siya, no? So, you can have it this way. Okay? For example, here is the centroid of that part. And then, you may have it this one. Okay, so that would be your bar X na hinahanap natin. And actually, the centroid, that's the centroid of the cross-section. Okay, kasi doon nakakonect sa base. Okay, so dito nakakonect yung pinaka, natin. So, mula dun sa centroid mo hanggang papunta doon, that would be our bar X. Okay, and that's actually this 29.81. Okay, and then the length of connection natin is 375, so that's around 225. So, we can solve for the U. U equals to 1 minus 29.81 divided by 225. Okay, so we will be having here as U equals to 0.87. Okay, so sa case 8 natin, okay, meron ka rin dong case 8. So, meron kang for single angle na merong bolts of 4 lines. Okay, so kapag apat yung bolts mo in the line of action of the load na paganto, so ilan yun? 1, 2, 3, and then 4. We may use U, sabi niya, equals to 0.8. Okay, so meron tayong dalawa, case 2, and then you have here the case 8. You are permitted to use larger of the two. So we will use U equals to 0.87. Okay? And then with that, pwede na tayong kumuha ng A sub n. Okay? So, A sub E, sorry. So, we can have it A sub E. Okay, that's again, U multiplied it by A sub n. So, this is 0.87. And then, 2,325.45. Okay, so this is now our A sub E. 0.87 times 2325.45. So you will do have here 2023.14. Okay? And that is in mm squared. Okay? So pwede na ako ngayon makakuha ng nominal. So that is equals to 400 as our FU. Multiplied it by the effective. So that's 2023.14. Divide ko na by 1,000 para maging kilonewton. So, you will be having here times natin ng 400 divided by 1,000. Okay, so you have here 809.26 millimeter square. Sorry. This is not millimeter square. So, this is in kilonewton. Okay. So, ngayon, check natin si LRFD, no? Okay. Using the LRFD. Okay. So, 1, due to yielding, we have here PU is equals to 0.9 of P sub N. So, ang P sub N ko is 54.86. So, that's around 0.9 times 654.86. So, that's equals to 489.37. Okay. And then another PU, so that's around 0.75. Kaya lang for the 809.26. So 0.75 of 809.26. So you have here 606.95. Okay. Since we will be having here 589, yung isa 606, we will use PU, smaller of the two, as 589.37 kilonewton. Okay? Now, this is now the capacity, no? So, this is your capacity. Okay. I-check naman natin due to the load. Okay. So, meron tayong due to the load. Due to load. Okay. Yung PU natin, again, may dead load and live load ka. So, you have here 1.2 dead load plus 1.6 of live load. So, ang 1.2 dead load natin is 88.96. And then, we will be having here 1.6 of live load is 266.89. Okay? So, check natin CPU. So, 1.2, 88.96 plus 1.6 of 266.89. So, you have here 533.77 kilonewton. Okay? Since, yan, yung capacity ko, yung muscle mo, mas malaki kumpara dun sa bubuhati niya, okay, so this now would be adequate, no, or safe. Adequate or safe. Using the LRFD, ganito yung ating solution. Okay, next. Using naman for our ASD, ganun din ang gagawin ko. So, kukunin ko muna si PA due to yielding, so that's around 654.86. I-divide ko by 1.67. So, you will be having here 0.86 divided by 1.67, and you will be having here 392.13 kilonewton. And then, for the rupture, that is divide by 2 naman, ano? So, you have here 809.26 divided by 2. So, you will be having here the PA 809.26 divided by 2. So, that's around 404.63 kilonewton. Okay? So, use Okay, we may use mas maliit sa dalawa, PA as 392.13. Okay? So, again, this is your capacity. Okay? Check natin yung due to load. Okay. So, we have PA equals to, pagsasamahin lang natin, again, the PA is unfactored load. So, we will be having here 88.96 plus 266.89. Okay. So, 88.96 plus 266.89, and that's around 355.85 kilo Newton. So, this is now your PA. Okay. Ang capacity ko is 392. Ang dadalhin lang niya is 355. So, with this, I can conclude that, again, this is adequate. Or you have here safe. Okay? So, this one is the answer. So, we verified the strength of our angle bars that could carry the dead load of 88.96 kilonewton and a live load of 266.89, both the LRFD and the ASD. Okay? So, that's how you check for the adequacy. No? So, given the loadings, and then you have the strength requirement, and then that's how you prove it. Okay? So, any question on this one? Okay. So, sige, save ko ulit.